Hi folks, thanks for joining. My name's Elton. I'm a Docker captain and a Microsoft MVP. I've been working with containers since like 2014. But before that, I spent most of my career as a .NET consultant, and I would have been watching a conference like this today and thinking like, this stuff's great. I totally get the advantage of microservices, but I'm going to work tomorrow with my big ugly monoliths, and none of that stuff appeals to me. So this session hopefully is going to try and convince you that these patterns still apply to you, even if you're working with an old monolith. So what I'm going to be talking about is taking these kind of big .NET framework monoliths, running them in Kubernetes, and then taking these microservice architectures and using them to evolve your architecture without doing a full 2-year rewrite of your application. So I've got a whole bunch of demos, got a few slides to kind of wrap things around. So the first thing I'm going to talk about is the approach. Now, I've been working with clients for the last few years, and a lot of people are really keen on this approach of, I've got these old .NET apps, they're my core business apps, so I want to keep running them, but I want to move them somewhere else. I want to run them on a modern platform. And then you get this kind of 3-phase approach, and I'm going to walk you through that in the next 25 minutes or so. The first one is the lift and shift, right? I've got my application running. I'm going to package it up so it runs in a container. I'm going to run that thing in Kubernetes. I'm going to spin up an AKS cluster that's got some Windows nodes and some Linux nodes, and I can run my 10-year-old application without any source code changes. And that's hugely beneficial. Now, people will tell you it's an anti-pattern, and certainly it's not microservices, right? There's a conflation between containers and Kubernetes and microservices, and they're not necessarily the same thing. Like, containers are great for microservices are great for containers, but you can run any old huge application in a container. You just won't get all the benefits of a microservice architecture. But by doing that lift and shift, and we'll see that in my first demo, you still get some serious benefits, and you're in a really good place then to start evolving that architecture. So phase 2 after the lift and shift is to kind of identify one of these boundaries that would make sense as a separate service and put a facade around it. So it's not a full-on microservice, because you can't always do that first time round. So it maybe doesn't encapsulate its own data, it doesn't own its own data, but you bring this kind of facade over some of the existing business logic, and that becomes your first kind of microservice. And then the final phase for that is to take the next step of making sure you do encapsulate that service. So it owns its own data. The monolith calls into that service. The only way to get the things you want from that particular part of the application is to call in through the microservice. I'm going to walk through all that stuff today. And this is just a kind of a very abridged list of why that stuff is important. So you've seen all the talks about microservices today. You've seen people talking about boundaries an awful lot, and people have different interpretations about that. And I think that's really cool. So the very first session, Scott and David were talking about the team boundary, this idea that these small components can be worked on by different teams and that you can distribute the work. And that's great. There are other kind of aspects of the boundary, but there are a couple of things that I think probably haven't been highlighted so much. But they really apply when I'm in this position of, I've got this old monolith, I want to do something with it. Why do I want to potentially move to Kubernetes and to microservices? Well, the first goal is I want a modern platform to run these things on. Like, I've got a bunch of Windows Server 2008 VMs in a data center somewhere, or I'm renting some machines from some non-standard cloud. I want to have a platform where I can run these things that's new, that's current, that's being evolved all the time and having new features, and it's portable. So I can run that stuff on my laptop as a developer. I can run it in my data center. I can run it in the cloud. It's the same thing everywhere. Really appealing to a lot of people to have a consistent way of deploying this stuff that's new. The new technology stack business, don't underestimate that, because as I'm talking with clients and people who are getting interested in Docker and Kubernetes, they get really excited by this stuff. And that's great, because I've been doing this for a long time, but I still get excited when the new release of Kubernetes comes out, when there's updates to Docker Desktop. If your team's enthused because they're doing some new stuff with new technology and new approaches, then happy team's going to produce better software. So don't underestimate that. And then coming back to that boundary point, so we've talked about team boundaries and the various levels of isolation that you get. It's not just about the runtime isolation. There's a boundary around release cadences. So if I've got these separate components, I can deploy them independently, scale them independently, and secure them separately. So if one of the demos I'm going to show you is making a part of the application publicly available as an API. Now, that's a secure boundary if it's within its own microservice, and there's no reason why, if somebody manages to break into that microservice, they can get to any other component. It's a security boundary around that particular application. Okay, so that's enough of the stuff. So I'm going to show you a bunch of stuff. All my demo code is all up in GitHub. That link in the bottom right there will take you to my demo samples that I'm going to walk through. The architecture of the first I'm going to deploy is it's the old .NET Pet Shop application. So it's a .NET 3.5 application. I got the code off of Codeplex and I put it into GitHub. I made one very small change, which you can read about if you want to, but fundamentally it's the same code that hasn't changed since 2008. So I packaged it up so it will run in a Windows container, and I've got an AKS cluster in Azure that's got some Linux nodes and some Windows nodes. Now, although this is an old monolithic application, I still want to do it properly with all the Kubernetes patterns. So the stuff that you heard Jessica talking about, I've got ingress coming in. So if you're not familiar with Kubernetes, I'm just going to kind of focus on the important parts here. So hopefully you won't get lost when we come to all the YAML specifications. I'm going to pick out the things that I think are important here. So the ingress pattern in Kubernetes is I have one thing where all the traffic from the cluster comes into this component called the ingress, and that routes it to different applications that are running. The benefit of that is that I have a single entry point, but of course other things can be put into that ingress. So I'm going to be using Nginx, which is a super popular, super performant reverse proxy. It can do routing, it can do caching, it can do sticky sessions, SSL termination, a whole bunch of stuff. So even though I've got my old .NET monolith that's sat on a Windows container in my Kubernetes cluster, I'm still fronting that with a brand new modern ingress approach. And my application itself is .NET 3.5. It runs on Windows Server 2019. But the way I model it, the way I spec out how my application is going to run, is with exactly the same Kubernetes API that I use for my brand new .NET 5 application, that I use for my Go applications. The API specification is exactly the same, apart from a couple of small things that I'll pull out. All the huge benefits that you get from Kubernetes, you still get with your monolith. Like, you haven't got all the flexibility. You can't scale up super quickly. There are other things that you can't quite do because you've got this great big lump sitting in a container, but you get a lot of the benefits of Kubernetes. Okay, so that's enough of the slides. I'm going to cut straight to my demo. So if you follow that link that's in the slides, you will get here on GitHub, which is my kind of cheat sheet for my demos. Everything that I'm going to walk through is all in here. So all these tons of YAML, I'm not going to go through it line by line because I'm going to painfully run out of time. But all that stuff's there if you want to investigate it yourself later on. In the Azure Markdown directory folder, that's everything I did to set up my cluster, which is just a bunch of AZ commands that create the cluster and add Windows nodes. Okay, so let's clear myself some space and open my terminal here. So I've already got my cluster running. If I look at all the nodes that are in my cluster, and if you're not familiar with this, the cluster is just a single entity that contains a whole bunch of servers that can run containers. I'm looking at those servers in Kubernetes are called nodes. I've got 4 nodes in my server. It happens that 2 of them are Linux, 2 of them are Windows. So it's I talk to it as one big unit, and it decides where to run the containers for me. Now, if I look more closely at one of those nodes, which happens to be one of my Windows nodes, Kubernetes has this kind of abstract label idea where I can apply any kind of key value pairs to all sorts of different objects. Nodes themselves have these labels that AKS applies for me. And there's a couple of things I want to point out. So one is it knows the operating system is Windows. So for this node, Kubernetes knows that it's a Windows node. And also it has this notion of topology. So these are in different availability zones in Azure. So kind of think of that as different racks within the data center. And Kubernetes knows that too. So as I'm telling Kubernetes to run my application, I can ask it to spread them around to make sure they run on Windows nodes, to spread them across different availability zones. I can capture all that inside my Kubernetes spec. So as we're looking at the YAML file and you're thinking, like, there's a ton of stuff in here, that's why. You can do all these sorts of really cool things in a platform agnostic way. Okay, so let's have a look at this. First thing I'm going to do, I'm going to be deploying stuff, and then I'm going to walk through what we've got. So I'm going to deploy my ingress, which is the thing that listens for all incoming traffic. So it's going to run Nginx in a bunch of pods. Again, if you're not familiar, a pod is just it's the abstraction of the runtime in Kubernetes. It's the process abstraction that runs your containers. So it's going to start Nginx in a pod with a whole bunch of other things. I'm going to look very quickly at some of the definitions there. So inside here, I've got, this is a configuration file. So my Nginx configuration, it comes with some kind of standard config, but I want to add caching to my proxy so that I can cache responses that come back. And the way I do that is with this thing called a config map that just contains a whole bunch of stuff which gets injected into the container file system. So when Nginx starts, it builds up its configuration model. It includes these pieces that I've specified. And so I get a kind of custom config in. So I've got caching enabled in my reverse proxy. And the other thing I've got in my service definition, so this is a service in Kubernetes is the networking abstraction that receives traffic. This in here it's a load balancer, but because it's working in Azure, I've already created a public IP address in Azure. I know what the IP address is, and I can include that in my Kubernetes manifest. So when I deploy this, my AKS cluster knows my public IP address is there. It creates the load balancer. It wires everything up for me. So it's all just kind of super simple. So Kubernetes has this nice abstraction where it can everything is kind of the same. Like your Kubernetes cluster is the same as mine, but there are integration points where the clouds can kind of take advantage of stuff like this. Okay, so those are the few things I'm going to point out. There's a lot more stuff in there, as you can imagine, but those are the kind of main points. So if I look now at the pods that are running, what I should see is I've got 2 pods that are already up and running. One is on node 1, one is on node 0. They're both Linux nodes, so they're up and running in Linux. That's fine. If I look at the service, what I should see, this is the IP address I requested. So that's bound to my public IP address. There's a load balancer there. It's distributing traffic across the nodes in my cluster. When they receive them, they come into my Nginx pod, and that's going to do stuff with them. Nothing yet because there aren't any apps there, but that's the ingress part. That was the green part in my diagram. Okay, so now I'm going to deploy the pet shop. Now, I'm not going to go through all the Docker files and stuff, but in the links here, it's in a separate repo. You can go and follow through, see how I've packaged up that .NET 3.5 app. It's just a pretty standard Docker file. There's not too much in there. That IP address isn't going to help me, so I'm going to deploy it now. And again, same thing. While this is all spinning up, we'll go and look at some of those things. There's a bunch of stuff getting created here because the modeling language in Kubernetes is super expressive, and you can do all sorts of interesting things. What I'm creating here are some configuration rules, some secrets, which again are like config, but they contain sensitive data. I'm creating my ingress rules that we're going to go through in a second. All those things are separate resources that all, as a whole, make my application. So if I close this down again and go and look at these files. So this is my configuration for my web application. So it's ASP.NET 3.5 app. It uses the XML configuration model. What I'm doing here is I've got a secret, so there's sensitive data in here with all my connection strings. So just like you could way back in .NET 1. Whatever, I've got my web.config file, and I can break sections of that XML into separate files, and that's what I'm doing. My Docker image is bundled with a web.config file with a bunch of common settings that expects to find a connection strings.config file with the connection strings in it. In Kubernetes, the connection strings config file comes from this secret, so it gets injected into the file system container, just like with the Nginx, but this happens to be XML, so my .NET app can read this. I've got these ingress rules, which are what tells the ingress controller to route traffic to my .NET web application, and it's slightly verbose, but the key thing here is I'm doing it based on a domain name. So any request that comes into my cluster, it comes in on that IP address. The ingress pod picks it up. If the host request is petshop.sixside.com, it's going to send it to the backend website, which is my ASP.NET website. There's a couple of other things in here. The old pet shop app isn't really stateless, and it kind of needs you to keep browsing to the same pod all the time. So I've got sticky sessions enabled with this annotation, which just tells the ingress controller that for these routes, send a cookie back to the browser. When you get that cookie back, route the request to the same pod. So as I scale up, I'm keeping sticky sessions. Super easy to do with just this. Don't need to change my code, don't need to change my application at all. The other thing I've got here is another ingress rule, which says it's the same endpoint, so it's the same host, petshop.sixside.com, but these are for the images. So there is no point asking a .NET 3.5 app to render a bunch of images when I've got Nginx that can do that for me. So what I'm doing here is I'm applying the cache for these particular routes. So when the requests start flowing through Nginx and the responses come back to Nginx from my app, the images get cached and then they'll get served from Nginx the next time, reduces a whole bunch of load going to my application. So it'll perform better for the real requests, which are the dynamic pages. Okay, and the last thing is the application itself. So this is the deployment spec. This is if you're not familiar with Kubernetes, this is just a big lump of YAML. And if you are familiar with Kubernetes, then quite possibly it's just a big lump of YAML. The reason I've got this stuff in here, and I'm really, if you saw Jessica's talk earlier, I'm really glad that I did this because I've covered all the best practices she said you should have. what I've got in here is I want to show you that this is a monolith, right? This is my 12-year-old application. All I've done is package it to run in a Docker container, but all those best practices still apply. So things like I've got in here my Readiness Probe, which says it's going to test the application inside the container, and Kubernetes won't send traffic to it unless it's ready to receive traffic. So it's just a nice little health check thing that helps my application be self-healing, and I don't need to do anything to my code for that. I'm just like pinging the home page every 20 seconds. I've got also in here, I've got my my resource requests. So that says my application, I'm expecting to use a certain amount of CPU and RAM, but I might be able to burst up to this if I need to, which just tells Kubernetes how to schedule it onto the right node and how to monitor it to see that it's doing what it should do. Things like the configuration all comes from those secrets and those config maps that I talked about. And these are all kind of good practices. And they work in the same way for my legacy application as they do for my new application. So I can take advantage of all those Kubernetes features. So like I said at the beginning, like this is not really the ideal because this container image is very big. It's a Windows image. It's got the based on the full Windows Server 2019. But I can still take advantage of what the platform gives me, which is a really nice kind of jumping off point. The last thing I wanted to point out here is I talked about those labels on my nodes, and this is where they come in. So Kubernetes doesn't know from my spec, from my container image, whether it's Windows or Linux. And I'm telling it here with my node selector, these things have to run on a Windows node. There's a bunch of other stuff there about affinity, which you can kind of explore at your depth. It's just about spreading the load around to different nodes, but they have to be Windows nodes. Okay, so those are the main things there. By now, that should all be up and running. So let's go and see. Clear that down. Oh, I've gone too far. Check my pods. So these are all in a separate namespace, which is just an isolation feature in Kubernetes. So I'm looking for my pods in my namespace. I'm running the database here. Let's say this is a test environment. Ordinarily, I would run a managed database and connect out. I've got 2 pods for my web application. And there's also, with the Pet Shop app, there's a WCF SOAP web service. I'm running that too, just to kind of prove that we can. So let's browse here. Or let's look at the ingest rules a second, just to make sure that everything's set up. That isn't going to help. So let's get my ingress rules. And what we'll see is they're all using that same IP address because everything is coming into my ingress controller. I can see the host and how they're being routed. Okay, so that all looks good. So let's browse and see if the thing works. It works. Cool. Okay. I'm sure like if we were here in person, I'm sure you'd all be clapping at this 12-year-old app that's running in AKS with no code changes. It was super fast to load. There was no kind of delay in loading up or refreshing it, and that's because of the health check, the container probe that's constantly pinging it to make sure it's up and running. Not only does that tell Kubernetes whether it's healthy and whether it should route traffic, but it also keeps the application warm. So it's using IIS under the covers. It spins up the worker process the first time a request comes in, but the first request was the health check. So it's super responsive. If I go and look at these things, like it works, which is a good thing. I can add stuff to my shopping cart. This wouldn't work if I didn't have sticky sessions because it would be load balanced and it would fail. I can go and browse these things. The other thing to show you, let's open the network tab, is if I refresh this a few times, what we'll see is there are 304s coming back, which is Nginx, helping the caching at the client side. And then also in here, if I refresh, if I do a control refresh a few times, get my network tab back up, and look at one of these images, we'll see that this was a cache hit. So that came from Nginx. It didn't touch my ASP.NET application. There's no need to serve a GIF from that. So this all comes from my cache. So I'm reducing the load that's going to my application. It's only doing the things that it needs to do. And when it does do those things that it needs to do, I've got sticky sessions enabled. And that's all from the ingress, which is standard Kubernetes pattern, works just as well for my monolith as it does for a brand new microservice. Okay, so the application works, so that's good. That's the first demo going well. The other thing we're going to look at is if I want to share my product list with my business partners, this is what I'm going to give them right now, which is a WSDL document that describes how to invoke my XML web service, which almost 0 of my customers or business partners want to see. So the next thing we're going to do is look at this kind of service facade that I talked about right at the beginning. I've done my lift and shift. My app works. Like, we're looking good. We're taking advantage of a lot of the features of Kubernetes, but it's still the same app. So let's switch back to the slides and look at what we're going to do next. Oh, too far. So the lift and shift, like I said, people are quite anti lift and shift, but I think it's a viable move. You know, if you've got an application where you don't have the source code anymore, you've just got a zip file that works on a server somewhere. Taking this approach and moving it here, if you're not actively developing that application, there's no dev team anymore. Being able to run it in Kubernetes and use the same tools and the same API language to define it as everything else is a huge benefit, I think. So I'm using all the features of Kubernetes, but it's still the same old application under the hood. So as it happens, we have got a dev team for this app, which is me. So we can now kind of take the next stage. So some apps might finish at the lift and shift stage, and some are going to carry on evolving. And the evolving part is the more interesting part. So the next stage here is I've still got everything that's currently running. So I've still got the ingress there that's bringing up the traffic and sending it to my pet shop app. I've got the database that's running in there. I've got a new thing here, which is my product service, and this is the microservice pattern that's coming in. It's not full microservice because it's still using the old database, but this is my facade. This is the first step in being able to break this thing up. And this is my new component, so I can do whatever I like here. I'm going to write a brand new REST API, so it's got a nice interface for consumers to use. It's going to be .NET 5, so I'm going to get all those super performance benefits that you heard about today, and it's cross-platform, so I can run it on Windows or Linux. And the benefit of that is, you know, as I start with the lift and shift approach, if I've got a bunch of .NET framework applications, I'm maybe going to create my Kubernetes cluster with a couple of Linux nodes and a dozen Windows nodes. But as I go down this journey of migrating and evolving these applications, more and more bits are going to be .NET 5 that could run in Linux, which is a bit more lightweight, it's a bit cheaper in terms of running those nodes. So I'm going to flip ultimately, and I'll have 8 Linux nodes and 4 Windows nodes. But I can tell Kubernetes that these applications are cross-platform, and it doesn't matter whether they run on Linux or Windows. Like, ideally, run them on Linux, but if there's not enough capacity, run them on my Windows node, and then I'm getting maximum utilization across my cluster. So that's like a huge benefit of being able to do this stuff. Okay, so let's go and see how that looks. So back to my demo bits here. So my product web service, again, all this is in that same source code repo. You follow the links, you better see where it is. So I'm going to go and deploy this now. So this is my brand new component. It's my .NET 5 component. So let's go and deploy all that stuff now. And if I look at the same, I'm going to take the same approach to have a look at some of these pieces. Connection strings, again, same idea. It's a Kubernetes secret, so it's a secure thing that it's got a separate management UI from UX from config maps, so I can secure them independently. And it gives the app whatever it needs. So my Nginx had its own custom conf file. My ASP.NET 3.5 app had XML. This is JSON, and it works in the same way. It gets delivered in the container file system. It gets managed by someone independently, and it's just got my sensitive data in there. I've also got ingress rule. This is for my REST API. So I've got a different domain name. So I'm going to api.petshop.sixside.com. If I wanted to, I could use my ordinary domain name and just have a path to take it to the API. This is sending it to my pet shop product service. This is the new component. This is a REST API. It's a read-only API. So everything's cached, but only for a short amount of time. So I've got a 2-minute cache in here. So, you know, if I'm getting 10,000 requests per second, 2-minute cache saves a lot of work going to my application. So that's a nice thing to have in there. And then again, if I look at my web deployment definition, I've got all those same kind of good practices in here. I've got my readiness probe. I've got my resource requests and limits. I've got my configuration being mounted inside the container. All that stuff is exactly the same. This lump of YAML is very similar to my monolithic application. One thing that is different is down here is my affinity for my nodes. So in the Windows example, it had to run on Windows, so I just used a selector. Because this is a cross-platform image, it can run on Windows or Linux. So what I'm saying here with the slightly scary name of required during scheduling, ignored during execution field, is I'm saying that this application, like, it has to run on either Linux or Windows. I don't have anything else in my cluster. They're either Linux or Windows, but it has to be one of those. And what I would prefer it if it was Linux. So I prefer if it was running in a nice lightweight Linux container on one of my Linux nodes. But that's just a preference. And if there are Windows nodes with more resources, it's fine to run on Windows. So nice little feature that you can take advantage of the fact that your application is cross-platform, get the best use of your cluster resources. Okay, so that should all be up and running. Let's have a look at these now. So all my pods, my database, web service, these are the new ones, my product service. I'm running 3 of those. If I have a look at the wide view, I will probably see they're all on the Linux nodes because the Windows nodes are using more CPU and memory. So as the scheduler in Kubernetes decides where to run pods, I've told it I prefer to run on Linux. It's put them all on Linux. If my Linux nodes were maxing CPU, it would put one on my Windows node. So, that's a choice that the cluster makes for me. And if I check the ingress rules, I'll see some new ones from my API. So let's paste that in there. I've got my api.petshop.6i.com, same IP address. The ingress is going to take care of all this stuff. Okay, so let's go and browse to this. Now this one, even though this is the new application, this one does have a little bit of a warm-up because the health check is just going to a specific health endpoint that doesn't do anything. So I'm not warming up the connection to Entity Framework or anything like that. So the first time I call this, there's a slight delay, but now I've got my nice shiny REST API, and it's like a proper API. So I can browse to a particular product within here, and I'll get that product back. This is being load balanced because I don't need sticky sessions for this. So it's going to be load balanced across my nodes, my pods. So now I've got another cold start issue, but then when I refresh, this is all being cached now. So if I open my network endpoint, you would see that this is coming from the cache. So it's all kind of super fast. Okay, so that all looks good. So that's cool. But that is not really the end goal. Now I've got this facade, but it's still using the original database. It's not really a service that kind of owns its own destiny. But the one benefit of this is if I go and look at the images. So this is Docker Hub. This is where I've got my images stored. This is the image for my brand new component, and it's a cross-platform image. So if you're not familiar with this, basically under the name of this, which is the 2007, being July 2020, there are Windows versions and Linux versions. The Linux version is 65 meg, and the Windows version, if I hadn't clicked on it, is 145 meg. It's based on Nano Server. It's pretty slim. It doesn't really matter which one of those run because they're nice small components. If I look at the original WCF app, that's going to be a different story because that's a Windows Server 2019 application. So the one I'm running is this one. That's 3.5 gigabytes compressed. By the time that uncompresses, it's pretty big, and the compression is quite tight, so it uses a lot of CPU. The reason this is important is it hurts when I want to scale. If I want to configure automatic scaling for my pods, which I can do, they're working too hard, Kubernetes will have more pods. I can configure automatic node scaling with AKS. So if there are pods that can't run because there aren't enough servers, AKS will have more Windows servers. But when the Windows server starts, Kubernetes asks it to run a pod. It downloads 3 gigabytes. It unzips it to 10 gigabytes. It takes however long it takes, 5 minutes maybe to be up and running. Whereas the other one, 100 megabytes, we can be up and running in no time. So that's why that's important. That's one of the reasons why it's important. Okay, so let's go back to our slides here. So I've done that kind of first part of the evolution. I've got this facade. I got my nice API that I can give to the public, and they can now consume my application. They can get a product list and build their apps of it and do whatever they want to do. I'm using the same tools for my old application and my new application. So Docker to package it, Kubernetes to run it. I've got this nice, lightweight, performant, multi-architecture runtime that I get with .NET 5. And I've got the security boundary that I talked about. So if someone manages to find an exploit and they can run remote code inside my product service, they can't really do too much because I could configure it so that the database user can only read products, and you can't do too much more than that. But the last thing we'll do is we're going to look at now that we've got this encapsulation. I want the pet shop application to call my product service, so it doesn't get products from the database, and that's going to allow then the team who own the product service to do whatever they want. So they're not tied to using that database anymore. They can go and shift to something completely different. We're going to be using Cosmos DB. So the old monolithic application will now rely entirely on the microservice to give it everything it needs, and the microservice can do whatever it wants under the covers. Okay, so very quick demo for the last part. So the first thing I'm going to do is I'm going to do an update of my pet shop app, and all this does is I really need to get my copy and paste game up, don't I? So let's copy that again. Okay, so all this does is I've added one new assembly to my monolithic application. I haven't changed a whole bunch of code. the pet shop application happily already has kind of dependency injection. So I've given it another way to go and find out where to load the products from using that service. And then if I go and browse to it now, the app settings are in here. The big change I've made is I've told it to go to this service to find products instead of the database. So now that's going to be nicely encapsulated. So if I go back here, clean this up a little bit and go back to the home page. So this is now, it still looks the same, still works nice and quickly, it still does the same stuff, but now it's calling into my pet shop service, my new microservice, and I can tell that if I go and look at the logs for that service, we should see a whole bunch of stuff coming in. And that's being, the pet shop app now is now entirely relying on the product service, my new microservice, to get everything about products. So now the product team can now go and do the update they want to do, which is to move to Cosmos instead of this kind of internal SQL database. Okay, let's try that again. If someone can write like a VS Code extension that will take things from code blocks and paste them in the terminal to make my demo so much smoother. Okay, and then again, the change to this is really just a tiny configuration change to say it's already got the code to be able to use Cosmos. I've already preloaded the data into Cosmos, a copy of the data. So now it's going to be looking at Cosmos DB for the data. So let's go and check this out to make sure it actually works. If I do a refresh, okay, that wasn't so good. Cool. Okay, so that's looking good. Now, so I've still got all my products in here. If I go and open my birds list here, of course, what I haven't done is kind of scale up for anyone who wants to be like throwing tons and tons of load at my application. Let's go and go here. Okay, cool. So this is what I expected to see. It still works in the same way. Up in Cosmos DB, I wrote a tiny application that pulls the products from SQL and puts them in Cosmos DB. So I can go and have a look at the stuff in Cosmos. And if I want to edit things, I can go and edit them. So I want to change Pelican to Pelicant. And if I go in here, and here's a joke for the old timers, I'm going to change Ant to Nant and click on update. And if I go back here now, we'll see something kind of interesting, hopefully. So if I go and look at the Pelican, there you see I've got Pelicant up here. If I go back to the list, it says Pelicant. If I go to my bugs, it says Nant. So the update is immediate. So it's come in through my API, and it's now flowing through into my application because the microservice owns its own data. I can do whatever I want to publish changes outside of the ordinary flow of the main application release. Okay, so just going to wrap up now. So let's go and go back to my slides. There we are. Okay, so that part 2 is really about having a real microservice. So I've taken effectively a chunk of stuff out of my old application, moved it to somewhere new, using a totally different data store, totally different technology stack altogether, and I've told the old app to use that. I had to make a small change to my monolith, like nothing significant, not a 2-week regression test thing. And I've now got a pattern that I can replicate for all of those boundaries. So, you know, the advantage of having a monolith to start with is you understand where the boundaries are going to be. You know, you can work those out based on, you know, what needs to be updated independently, what gets more traffic, whatever, you know, whatever criteria fit for you. You may find slight problems. So if you spend enough time looking at the pet shop, you'll find that it doesn't quite work correctly. But, you know, that's something you're going to come out with the fact that I've got a 12-year-old app and I'm trying to do as little work as possible to evolve it into something new. Okay, and we're done. So if all this stuff was totally new to you, there's a whole bunch of links here that are hopefully useful. That top link, DAC for .NET, I do like a whole day workshop, and all the content is online. You can just go and follow along with it yourself at home, and that starts from zero. So it tells you about how containers work, tells you how to wrap up .NET Framework apps and .NET Core apps and how to run them in Kubernetes, and it takes you from zero to, you know, to be able to understand this presentation. I've written 2 books. Learn Docker in a month of lunches, learn Kubernetes in a month of lunches. If you follow those links, there's like a giveaway. I've got a few copies to give away. If you don't win one of those, then there's a discount code from Manning where you can get some money off. And today's demos are all up there on GitHub. You can follow all that stuff through yourself, create your own AKS cluster, and see if the Pet Shop app kind of works for you. So I hope that was useful. My name's Elton. Thank you for joining, and I hope you enjoy the rest of the day.
Thank you very much, Elton. We unfortunately are out of time. We do have one question out on Twitter. So if you look at the .NET Conf hashtag, I think you can answer that for them.
Okay, cool. I will do
Perfect. It was a great presentation. I was trying to looking at it. I was doing some quick searches on the internet, trying to figure out all the content. I love the style. Great job.
Okay, thanks very much.